Good day, MET330 students. In this video, we're going to talk about FORTRAN's selective control statements and how that can aid us in creating more complex programs. So you might be asking yourselves, what is selective control? Well, selective control is a way that we can say to the computer, only do these certain tasks if certain conditions are met. And so this helps us refine our problem solving. And so this will still happen in sequential order, but that we can kind of have some branches for doing some things or calculating things in a slightly different way depending on what parameters we set up. And so the question is, how does this computer make choices? The main thing here that our computer needs is it needs logic, right? Because it can't think for itself. And so we need to develop something where we can have the computer assess for itself whether something is true or false. And so ultimately we need logical statements. And so all the time we are basically faced with logical statements in our own lives. We don't necessarily think about them in that way, but it's true. And so here are the main logical statements that in FORTRAN we have to use these symbols on the left-hand side for governing our logical statements to be able to be ascertained as true or false. You may know them more through their mathematical symbols, and so keep this table handy to help you. The dots are important, and so less than is dot less than dot, or dot lt dot, greater than gt dot is equal to dot eq dot, less than or equal to, greater than or equal to, or not equal to. And so what we're going to have to do to use these logical statements within FORTRAN is set up what we call logical statements that use expressions through one of these operators to then determine whether something is true or not. And so here we have 5 less than 10. Is that a true statement or a false statement? Of course it's a true statement, right? 5 is less than 10. And so this expression, this overall expression, would get the value true. And so recall that we have that data type that can be logical, although we don't have to define these things necessarily as logical, but that logical statements can be true or false. Now, those are the simple ones, but we can actually then combine things because sometimes we have, if one or the other thing is true, then we want to do something, or we need two things to be true, so this and that to be true. And so we have a couple of logical operators here that are for more complex expressions. And so, for example, earning a B+ requires that your grade be less than 90 and greater than or equal to 87. And so we would use the AND logical operator there. Another common one to use would be OR, right? If one or another thing, if A or B is true, then I'm going to go forward. And so here are these definitions of not A is true if A is false, right? So we're basically saying, I want to make sure A is false. If it's not false, then good. I'm true. That's something I desire. A and B is something called the conjunction of A and B, right? We want both, so both need to be true. Or the disjunction of A and B, and so it will be true if A or B is true, or both are true, and false otherwise. And then we've got these equivalents and non-equivalents. We're not going to use those in this course, but they're here for completeness sake. Again, for more information, please see the FORTRAN 77 for scientists and engineers for more information and examples. So let's see a little bit about how this would work. And so, again, logical variables can take on our values of true or false. And so here we're setting up a simple program with two integers, x and y, and a logical variable called flag. And so here we set x equal to 5 and we assign y equals to 9. And then we have the statement flag is assigned y.lt.x. And so we need to plug in for our variables here. And so we're saying, is 9 less than x? Is that a true statement or a false statement? 9 is less than 5. That's false. And so our variable flag would be assigned the value false. And when we print it out to the screen to standard output, we would print false to the screen. There's example code that you can see in MET330 logical.4 if you wish to look at a bit more example code. We're going to see some examples in a future video. Alright, so great. So we can do that. We can assess if something is true or false. But how does that really help us? In this sequential execution, right, we're going from statement to statement to statement to do something. For example, we're reading in a temperature, we're converting that temperature, we're outputting it. But what if we had a temperature that could be from any unit and we wanted to express it in any unit? We could use if statements to help us choose which conversions to do and how to do them. And so a part of all programs are sequential, but some selections may require just doing one task or multiple tasks. And that this idea of using logical statements will help us to parse out what to do and when to do it. And so what does this idea of selective control really mean to you? Go ahead and write yourself a sentence or two to think about what this idea of selective control would mean. Right, so here this idea of selective control is the selection of a single outcome from two or more possibilities, or two or more possible results from some known input. Okay, so that's a more formal definition. So now go ahead and take a moment and construct a selective control example from your everyday life. Right, think about how you make choices to do something or not to do something. And go ahead and briefly write it out. Feel free to pause the video in order to do this. There are so many examples that one could use for this everyday life example. So for example, I might say if my car produces less emissions than required, then my car passes the test. Otherwise, if my car doesn't produce less emissions than required, my car fails the test and I have to fix it. An example you might have come up with is, if it's lunchtime and I'm hungry, then I'll go get food. Otherwise, I'll continue working. Right? Our life is filled with this idea of selective control. Now, for the most part, this happens in the background. But again, computers are dumb and will only do the things we tell it to do. And so we have to explicitly write this out for computers. So the question is then, how do we do that? In computer programming, it's called if-then statements. And so here is the syntax structure for FORTRAN if-then statements. Our if-then statement starts with if, and then within parentheses we have that logical expression, so say 5 less than 10. If this logical expression is evaluated as true, then it will go and do whatever is contained within this if statement. For writing if statements, we always want to make sure that we indent by a couple of spaces. 4 is pretty standard. Anything that is supposed to happen if this expression is true. And then to end our if statement, we need end if. And so here is an example. If we got minute from some sort of standard input or from the computer in some way, if the minute is less than 15, then take the hour and assign it a new value of hour minus 1 and the end if statement. Right? This might be something you use in meteorology at the top of the hour when we don't necessarily have new data in yet, and so we still want to use the previous hours of data if we're, say, plotting something. or doing an analysis. This is the example of a simple if statement that has one logical expression with one possible thing to happen that then, if it's not true, just won't happen. We can get more complex. The full if, else statement is structured as this. And so we can have if, one logical expression, then do this. And if this is true, then it's only going to produce and work this first statement sequence and then move on to the end if and continue on with our sequential program. But if this statement is false, then it's going to try this next statement and see if it's true. If it's true, then it'll do its statement sequence and then move on to end if and move on with our program. If neither if logical expression or else if logical expression is true, then it will do else, otherwise. And we'll do that and then move on, end if with the rest of our statement. We can have any number of else-if statements contained in an if-else-if structure. We also don't have to have an else. Okay? Again, as in our previous example here, we need an if, then, and an end if in every single if statement. Then we can add any combination of else-ifs and only one else statement to a complex if-else-if statement sequence. That's it on the structure. In a future video, we're going to work through some examples about doing if-else-if statements with actual coding. Hope this helps unlock some of the mysteries of selective control and if-then statements in the FORTRAN computer programming language. Thanks for watching.